All right, in this video, let's look at a slightly more complicated example of applying the DEWNC to a system where the mechanical energy changes. So I have a roller coaster. It has a mass of 2,500 kilograms, moving at a speed of 10 meters per second with a initial height on the first hill of 15 meters. And then that roller coaster is going to go down the hill, come back up the other side, and on this other hill it's going to have an elevation of 8 meters and a new speed of 12 meters per second. So we'll call this V2 is 12 meters per second at a height of 8, and V1 is 10 meters per second. Now, if there was no friction or no drag involved, then we could say that delta E is 0. We could say the UG and K here is equal to the UG and K here, and then solve it. But this is not the case when we have non-conservative forces. When we have the force of friction that's doing work, what happens is this delta E decreases. So we have to use the delta E is equal to the work done by the non-conservative forces. And now we don't know if it's friction and drag. It's probably both in this case. So let's just solve for the total work done by non-conservative forces. So delta E will be the difference between the total mechanical energy at position 2, call this position 2, call this position 1, minus the total mechanical energy at position 1. And that'll equal the work done by non-conservative forces. Well, we know at position 2, we have the kinetic energy here plus the UG here. And at position 1, we have the potential energy here plus the kinetic energy here in either order. So E2, this will just be K2 plus UG2, but let's put the kinetics together. This will be like basically K2 minus K1 plus UG2 minus UG1. So this is my delta K plus my delta UG, and that's going to equal the work done by non-conservative forces. So let's combine these. So the K2 will be 1/2 mass V2 squared minus 1/2 mass V1 squared, then plus mg delta Y2 minus mg delta Y1 will equal the work done by non-conservative forces. So we could factor out the 1/2 m and do V2 squared minus V1 squared, and then mg and do Y2 minus Y1. Why don't we do that? So we have 1/2 m V2 squared minus V1 squared. Sorry. And then add that to mg delta Y2 minus delta Y1 equals work done by non-conservative forces. So if you go ahead and substitute all these values in, you have 1/2 2,500. I'm going to cheat a little bit and drop some of the units just so I can fit this all on the screen, on the page. And this is Y2, which is 8 meters, minus Y1, which is 15 meters. And we would expect this to be negative because it's losing mechanical energy due to friction. And when we go ahead and calculate this out, we get that the work done by non-conservative forces is negative 116,500 joules. So what that means is from position 1 to position 2, the cart lost 116,500 joules of mechanical energy, and that energy was converted into thermal energy due to the non-conservative work done by friction and drag as the roller coaster went through its path.